So this is the last section of the course dealing with average value of a function. And when we talk about the average value, it's the average y value or average value of f of x. Now, in order to find the average of any set of numbers, you simply add them all up and divide by however many is there. So when we have a finite number of y values, this is what we would just indicate it as. I'm just using the book's notation, y sub av, so AVE here. So it's the average y value. And again, here we are just adding up all the y values. If we have n y values, we add them all up, we divide by n, telling us how many values we have. When we have an infinite number of y values, we bring in calculus. So these are the two notations we can see. It's the average y value or the average value of f of x. It's simply equal to 1 over the difference between b and a. So this is when we're on a closed interval from a to b. So it becomes 1 over b minus a times the integral from a to b of f of x dx. So it's a rather simple calculation. There's no graphing involved. We could graph at the end if we wanted to, just to double check, just to illustrate. So let's take a look at our first example. We're going to find the average value of y on the closed interval from 0 to 3, given that y is equal to the opposite of x squared over 2. So again, this is something that I would just say maybe graph on Desmos and then cut off the graph from just 0 to 3, x equals 0 to x equals 3, and then you could find the average y value there. So again, how we just want to denote this, the average y value is going to be 1 over the difference between a or b minus a. So b is 3, so we're going to say 3 minus 0 times the integral from 0 to 3 of f of x, which is just negative x squared over 2 dx. So we're going to get 1/3. I'm going to pull the 1/2 out in front, actually a negative 1/2, times the integral from 0 to 3 of just x squared dx. So we could say that this is negative 1/6 times the antiderivative here, x cubed over 3 from x equals 0 to x equals 3. So we're going to get negative 1/6. 3 cubed is 27, divided by 3 is 9, and then we get a minus 0. So we're going to get negative 9/6, or we could simplify this to negative 3/2. So of all the infinite y values that show up from x equals 0 to x equals 3, that's the one that would technically be right in the middle, the average y value. All right, let's just do a couple more. But in these next two, I'm actually going to ask another question as well. Here we want to find the average value of the function f of x, which is equal to 1 plus x squared, on the closed interval from x equals negative 1 to x equals 2. Now, because this is just using f of x, I'm going to just denote it this way. The average f of x value is going to become, and we just have to be careful with our signs, 1 over, remember it's b minus a, so 2 minus a negative 1, times the integral from negative 1 to 2 of 1 plus x squared dx. Now this will become a 1/3. 2 minus a negative 1 becomes 2 plus 1, so 1/3. And we'll just say times the antiderivative here will give us x plus x cubed over 3 from negative 1 to 2. So you have to be careful here. There's no 0 involved. So we're going to have 2. 2 cubed is 8, so plus 8/3, minus, in parentheses, we're going to have a negative 1. Negative 1 cubed is negative 1, so we're going to get a negative 1/3 here. We just have to watch our calculations. All right, now over here, I'm going to go ahead and say this is 2 minus a negative 1 will give us a 3. Then we'll have plus 8/3. Minus a negative 1/3 will become plus 1/3. So we're going to have 1/3. Then this is 3. 8/3 and 1/3 is 9/3, so we're going to get 3. So we're going to get 6, a third of 6, which will give us 2. Now our next question, this is the average y value. I want to know, when does y equal 2 occur? So what I'm going to do is we're going to set the average y value equal to our function. So we're going to set 2 equal, our function was 1 plus x squared. So in other words, I'm looking for the x values. So let's just solve this for x, subtract a 1. And then this is going to occur when x is plus or minus 1. Now again, we are on the closed interval from -1 to 2. So -1 is definitely in this interval, so is 1. So it occurs when x equals either a +1 or a -1. All right, let's just try one more. Here we're going to find the average value of the function f of x is equal to sine of 4x on the closed interval from -pi to pi, and again when it occurs. So if we're going to find the x values that this happens. So if you'd like to pause the video and give this a try, feel free to. Again, because this is f of x, I'm just going to denote it this way. We're going to have 1 over, we're going to get pi minus a negative pi times the integral from -pi to pi of sine of 4x dx. So this will give us 1 over pi plus pi, so 2 pi. Now here we actually have to use some u substitution. I know it's been a while since we had to do that, but that's going back to section 4.5. So we're going to let u equal the 4x. And then du over dx is going to equal 4. And then solve this for dx. So then du over 4 is going to equal dx. Now again, because we're using u is equal to 4x, I need to change the -pi to pi. So when x is equal to -pi, u is going to equal -4 pi. And when x is equal to pi, u is going to equal 4 pi. So this is going to become times the integral from -4 pi to 4 pi of sine of u times du over 4. So now what this is going to do, I'm going to pull the 1/4 out in front. So multiplying 1 over 2 pi times 1 over 4, we're going to get 1 over 8 pi. And then the antiderivative of sine u is going to be a negative cosine u. And again, as u is from -4 pi to 4 pi. All right, so again, the reason we changed the x's to u's now, I don't have to bring the 4x back in. If you left it -pi to pi, at this point, you would just bring the 4x back in instead of the u and evaluate there. So we're going to get 1 over 8 pi times negative cosine of 4 pi minus a negative cosine of -4 pi. All right, so just to indicate what 4 pi is, if we go around the unit circle, we start at 0. When we make one full rotation, that's 2 pi. So if we go around again, then we would be at another 2 pi or 4 pi. So we're still looking at the ordered pair of 1, 0 right here. So we would get 2 pi, 4 pi, 6 pi would all bring us back to this point at 1, 0. So cosine is going to be a 1. So we're going to get 1 over 8 pi times the opposite of 1 minus, here again we'll have the opposite of 1. So inside here we're going to get a -1 plus 1, which is 0, and 0 times anything is 0. So the average y value is 0. When does it occur? So all we have to do is go back up and set sine of 4x equal to 0. And again, we can think of this as sine of what is going to give us 0. So we're at 0. Sine is 0. At 0, it's also at pi, and then at 2 pi as well. But keep in mind, we have to stay between -pi and pi. So what that means is if we're looking at negative pi, we would go around in a clockwise rotation. This will give us to negative pi. So if we started there and went back around, this is really the rotation we're starting at. So this is negative pi. Again, it's at the same location, and we're going to go around this way. So this is really what it's saying is negative pi to pi. So again, if we think back to sine of u is equal to 0, this is going to happen when u is equal to negative pi, 0, and then pi. But now we have to bring the 4x back in, so this means 4x is going to equal negative pi, 4x is going to equal 0, and then 4x is going to equal pi. Then we just divide everything by 4. So x is going to equal negative pi over 4, x is going to equal 0, and then x is going to equal pi over 4. So a little more challenging with this one. So this average y value of 0 occurs when x is negative pi over 4, 0, and then pi over 4. All right, so that wraps up the lessons. Please let me know if you guys have any questions.